Hello everyone, this is Nehal Elshamy from Class 3E, and I'm going to explain the nanoscience, nanoparticles, nanofabrication, and nanotubes. First of all, what is nanoscience? Nanoscience is the study of phenomena and manipulation of materials at atomic, molecular, and macromolecular scales, where properties differ significantly from those at a larger scale. This means that the same material, for example gold, at the nanoscale can have properties, whether optical, mechanical, and electrical, which are very different from and even opposite to the properties of the material has at the macroscale, which is called bulk. Properties like electrical conductivity, color, strength, and weight change when the nanoscale level is reached, which means that the same metal can become a semiconductor or an insulator at the nanoscale. What is the nanometer scale? The nanometer scale is conventionally defined as 1 to 100 nanometers. 1 nanometer is 1 billionth of a meter, 10 to 9 meter. The size range is normally set to a minimum of 1 nanometer to avoid single atoms or very small groups of atoms being designated as nano-objects. Therefore, we can say that nanoscience is the study of material that exhibit remarkable properties, functionality, and phenomena due to the influence of small dimensions. Nanoscience is an interdisciplinary science, which means that it involves concepts of more than one discipline, such as chemistry, physics, etc. Here in this photo, we have chemistry, biology, physics, molecular biology, engineering, surface science, and biotechnology. In other words, nanoscience is thus a horizontal integrating interdisciplinary science that cuts across all vertical sciences and engineering disciplines. What are nanotechnologies? Nanotechnologies are the design, characterization, production, and application of structures, devices, and systems by controlling shape and size at the nanometer scale. This definition of nanotechnologies doesn't generally include the non-intentionally made nanomaterials, which refers to the nanoscience particles or materials that belong naturally to the environment, like proteins and viruses. It therefore it's not limited to the intentionally made nanomaterials, which refers to the nanomaterials produced through a definite fabrication process. Nanotechnologies are horizontal enabling conversion technologies which cross all vertical industry sectors as shown here in this photo. Now, what is a nanomaterial? A nanomaterial is obviously an object that has at least one dimension in the nanometer scale, approximately from 1 to 100 nanometers. Nanomaterials are also categorized according to their dimensions. So, how small are nanomaterials? Nanomaterials are larger than a single atom, but smaller than bacteria and cells. Here, this is the cells, and these are the glucose. This is the range that a nanomaterial is in. But what makes nano special? Why is it special? An exceptional property of nanomaterials is that they can be fabricated atom by atom. And this process is called bottom up. Nanomaterials also have increased surface to volume ratio, which means that the surface is more than the volume ratio compared to the bulk materials. The bulk materials are the larger materials of these materials, just how we mentioned up. And this has an important consequences for all of these processes that occur on the surface material, such as catalysis and detection. Which means that as you increase the surface volume ratio, the catalysis process increases as well. Also, there is a direct consequence of the small size of nanomaterials, physically explained as quantum effects. For instance, the bulk, which is a large piece of silver, is non-toxic, whereas silver nanoparticles, the smaller ones, are capable of killing viruses upon contact. And the last thing is that nanomaterials are classified into four types according to their dimensions. As we said above, that nanomaterials are classified according to their dimensions. There are four types, and we're going to go through them one by one. The first one is the zero-dimensional nanomaterials. Here, all the dimensions, the x and y and z, are at nanoscales, which means that no dimensions are greater than 100 nanometer. This includes nanospheres and nanoclusters. So what is a nanosphere? It is also called a buckyball. What is a buckyball? Buckyballs are also called fullerenes, were one of the first nanoparticles discovered that are composed of carbon atoms. This is a buckyball. They are linked to three other carbon atoms by covalent bonds. So what would link one buckyball to the other buckyball is a covalent bond. And they are made of carbon atoms. The most common buckyball contains 60 carbon atoms and is sometimes called C60. Other sizes of buckyballs range from those containing 20 carbon atoms to those containing more than 100 carbon atoms. Now, for the second type in the nanomaterials is the one-dimensional nanometers. So this is the zero-dimensional, and here is the one-dimensional. Here, two dimensions, x, y, are two nanoscales, and the other is outside the nanoscale. This leads to needle-shaped nanomaterial. It includes nanofibers, nanotubes, and nanorods, and even nanowires. This is a nanotube, and this is how it looks as a one-dimensional nanomaterial. As for the third type, it is called the two-dimensional nanomaterials. Here, one dimension X is at a nanoscale, and the other two are outside the scale. The 2D nanomaterials exhibit plate-like shapes. It includes nanofilms, nanolayers, and nanocoatings with nanometer thicknesses. As for the fourth type, it is the three-dimensional nanomaterials. These are the nanomaterials that are not confined to the nanoscale in any dimension. These materials have three arbitrary dimensions above 100 nanometers. This is a summary of the shapes of the four types of the nanomaterials: the zero dimension, the buckyball, the one dimension, the carbon nanotube, the two dimension, the graphene, and the 3D, the three dimensions, is the graphite. This is all about the types of nanomaterials and what makes nanotechnology special, what is a nanomaterial and how small it is. This is the scale of the nanomaterial, the definitions of nanomaterials, nanotechnologies, nanoscience, and that's it for the nanoscience. And thank you for listening.